So the warm-up question says, Mr. Boyd is done showing off his mad skateboarding skills when he coasts to a stop from 1.2 seconds to 3.4 seconds as shown in the graph. So it's obviously this portion here that is in red where you have a curve. Find his acceleration during that time. Find his stopping distance. So you have a couple of questions that you need to answer here. But I'm asking you to do a calculation, but I didn't give you a ton of information, at least not in the actual question itself. But there is information in the graph. Okay, so it's kind of similar to the types of questions you guys were answering in the My Open Math assignment where there was information in the picture. Okay, so you can still get the information you need to solve for this. So let's go ahead and label the information that we're given. We're trying to solve for acceleration and stopping distance. There's two different questions here. So we'll go ahead and solve for the acceleration first. The time is 2.2 seconds, and I got that because that is from 1.2 to 3.4. That is a 2.2 second period of time. Okay, so you can just subtract those two numbers there to figure out the change in time there. My final velocity is 0. Again, that's not in the question, but it is in the graph. Okay, how fast are you going at the end of that? Well, it's a horizontal line right here. Okay, and it says in the question slows to a stop. So you can see it right here as well. Okay, so my final velocity is 0. My initial velocity, okay, is not, again, given to me, but how am I going to figure out how fast I'm going at the start of this at 1.2 seconds? Yeah, the slope, rise over run, because this is a straight line going into that curve. So you just need to find the slope of that little green line segment there, okay, which is rise 15 over run 1.2. 15 divided by 1.2 is 12.5. It's positive 12.5 specifically because it's in the forward direction on my graph. That should be in meters per second. I don't think I typed the units. Okay, so that's the information I'm given. The time, the final velocity, the initial velocity, and I'm trying to find stopping distance, and I'm trying to find acceleration. Looking for two different things here. Okay, so looking at these equations, if I have t, vf, and vi, I can find delta x, and I can find a. I'm going to use two different equations for that, or I can find one and use it to find the other. Okay, there are multiple options here for how you want to approach this. But if I want to pick an equation to find, I'm going to do A first. I don't know why I labeled them backwards here, but calculate acceleration is written first. But if I want to find acceleration, I'm going to use equation A because I have VF, VI, and T. And so if I want to find A, this is the perfect equation to do that because I know this, this, and this is what I'm looking for. And so I can solve for A. And then if I want to find delta x, I can use that A to find delta x with this equation, or you have the option, if you want to, you could use, actually really any of them that had delta x in it at that point. But like equation D, I could just use the information I currently have labeled, and that would work too. Okay, so there's more than one way to do this, but I'm going to go ahead and use this one. Okay, so I'm going to find the acceleration, and I'm going to use it to find delta x. So we're going to substitute in, starting with this equation, VF equals VI plus A times T. Here is VF, here is VI, plus A times T. Okay, so when we start to solve, when we start to manipulate these variables, we're going to subtract 12.5 from both sides. That becomes 0 minus 12.5 equals A times 2.2. Which is this, negative 12.5 equals 2.2a. And then we're going to divide both sides by 2.2 in order to isolate our variable. And when we divide that in the calculator, we find an acceleration of negative 5.682 meters per second every second, or meters per second squared, meters per second, however you want to write that unit. Okay, that would be the acceleration. Makes sense that it's negative because he's slowing down. Okay, he's going forward, slowing down. So forward is going to be positive velocity. Slowing down means my acceleration has to be opposite. Yes?
Since this is on open math, we round it to 2 decimal points.
Yeah, it should work fine. You can type it like that, or if you want it, you should accept negative 5.68. Okay, any questions about the calculation for this first question? All right, let's try the next one. All right, so now that I have found the acceleration, I went ahead and added it right here. Okay, so now we're going to solve for delta x using this equation, although you have other options. You don't have to use that one, but that's the one I'm going to use. Okay, so to solve this, delta x equals VI, again 12.5 times 2.2 plus 1/2. Here's my new value for A that I just found, times t squared. Again, we're going to multiply the pieces that we can. That becomes 27.5. This is half of negative 5.682 is negative 2.841, and then times 2.2 squared. Okay, 2.2 squared is 4.84. Okay, so now we can multiply those values together, and we have 27.5 plus negative 13.75, which means we're really subtracting. 27.5 minus 13.75 is 13.75. Okay, and so the displacement that the object experiences, or object, Mr. Boyd experiences, is 13.75 meters forward, because he was already moving forward, but slowing down. He's still going to move forward until he stops. And by the way, you have an idea of what his displacement should be simply by looking at this graph. Now, you can't see the exact value here, but he goes from this position when he starts to slow down at about 15, and he goes up to a little under 30, and so yeah, that's about 13.75 meters. So you can kind of get an idea of where it should have been ballpark. You can kind of double check it that way with the graph, but you couldn't figure out the exact number without actually solving it. Okay, does anybody have a question about the warm-up?
Will the exponent always be in the parentheses?
You mean the 2.2 squared? You don't have to type it in parentheses.
Yeah, I just.
You don't have to type it that way. All right, but you do need to make sure you're only squaring the 2.2 and not both of the numbers. But you don't have to put it in parentheses to do that. Okay, any other questions? Okay. All right. Then I don't have anything else to go over with you today, because we are pretty much done with the material in this unit. In fact, you guys have a quiz on Tuesday. You don't have school on Monday, so the day you come back from your nice long 3-day weekend, you're going to be taking a quiz, and then you have a test on Thursday. So today, and I mentioned this yesterday, you have a CFU. It is titled 204 Acceleration CFU. You will find it in My Open Math. It is also linked in Schoology, but you can go through Schoology, or you're already in My Open Math, so you should just be able to get to it from there. It is due by 11:59 p.m. tonight. You can use your notes. You can work with another person. Again, you do have randomized values, so just be aware of that. You only get one try for full credit. That's what I mean whenever I say CFU. Okay, so it's not going to give you multiple attempts for partial credit. That said, I did still leave the multiple attempts on if you want to use it for practice, but you're only going to get credit for your first response. Okay, so please keep that in mind as you're working. I would definitely take out some paper if you don't already have some out, because I don't want you trying to do all of the math in your head or on your calculator screen. I would write it out. That's going to make sure that you don't make any silly mistakes, and it's going to help you choose the correct equation for the calculations. This is pretty short. I think it only has 12 questions, so chances are you're going to finish it before the end of the period, and if you do that, my recommendation at that time would be to work on the unit summary, because again, you have a test coming up next week and a quiz on Tuesday. So your unit summary you can work on. If you didn't finish the card sort from last night, you can work on that. I did just post the answer key for that. But that is what you are working on today, is 204 Acceleration CFU. Hopefully you finished it in class. I can't imagine that you wouldn't. But if for some reason you don't, it is due by 11:59 p.m. tonight. If you guys have questions, please let me know.